Sometimes in computer graphics it's important to be able to come up with a way of finding the image of original points and moving those points around the Cartesian plane. Some of these transformations, these movements of points, could be a reflection, where we pick, say, one of the axes, the X and Y axis, and reflect points in that. Rotations are another common. Rotation's another one. Dilations, where things are reduced in size. Magnifications, shears, etc. There's quite a few transformations. We're only going to deal here with reflections and rotations, and maybe having a look at a little bit of shear transformations. So basically what we can do is, if we've got an original point and it is reflected, and in this case we'll just pick on an easy one here, and we're going to reflect. So here's my y-axis and here's my x-axis, and we've got the point P, x, y, and we're going to reflect that in the x-axis. So if you like, the x-axis is like a mirror, and this point, this image or this original point, will be so far in front of the mirror. Here's my mirror. I'll just shade it like that to show that it is a mirror. So this is a reflection in the x-axis. I'll denote that by Rx, so a reflection in the x-axis. And you know from some basic science work that if a point is so far in front, a reflection, the image, we'll call it P dash, will be the same distance away. And just by a bit of coordinate geometry here, if that is x units out, this is going to be x units out, and the y coordinate, if that is positive y going up there, well, if that distance is the same as that distance, then this will be negative y. So that's a simple example, but it may be useful to be able to come up with some way of using matrices to be able to transform any point x, y through a reflection in the x-axis into its image, and to come up with the coordinates of where the image may lie. So this is the original, and this is the image. Okay, so it's really quite easy. The original point we will put down as x, y. Now we're going to put a matrix here, and this is the original, and the image, we've got to get x minus y. Now, from knowledge of matrices and matrix multiplication, here we have a 2 by 1, and our answer is a 2 by 1, so it is 2 rows and 1 column. So this one here is going to be a 2 by 2, bearing in mind that to be able to do matrix multiplication, the inner dimensions have to be the same, and the outer dimensions will give us our dimensions of our final result. Okay, now with all of these, with reflections, rotations, dilations, whatever, the way we make up the matrix is have a look. This column here, which is going to be 2, there's going to be a 1 there and 1 there. What happens to the point 1, 0? So if I was to put the point 1, 0 down there, if that is reflected in the x-axis, where does the final image become? So 1, 0. So it's not anywhere, well, there's no distance in front, it's right in the mirror. So that point's going to stay at 1, 0. So you write that down as a vertical column. So 1, 0 is the image of the point 1, 0. To get the second column, we look at what happens to the point 0, 1. Now if we're looking at a reflection in the x-axis, the point 0, 1, what happens to it? 0, 1, if it is reflected, it is going to go down there to 0, negative 1. So that becomes my second column. Okay, so now we've got, by matrix multiplication, 1, 0, turn it sideways, you've got 1 times x is x, 0 times y is y, so 0 times y is 0. So we've got x plus 0 and we get x. And that's all we get in the first element there. And then to turn this sideways, we've got a 0 up there, -1. 0 times x is 0, and -1 times y is -y. And you add the two together, 0 plus -y, and you get -y. So that applies to all transformations. This is a reflection. Let's have a look at a reflection in the y-axis. So we've got our y and our x, and we've got the point pxy. Now it is going to end up over there, and I think intuitively you know what the coordinates are there, but we'll work it out by using matrices. So we've got xy as our original point, and let's come up with the matrix for the transformation. So this is going to be a reflection in the y-axis. So this here, if you like, is like my mirror. What happens to the point 1, 0? Okay, if this is reflection in the y-axis, 1, 0 is going, it's always 1, 0, start with what happens to 1, 0. 1, 0 will go to -1, 0. So I write that down as a column. And the second point we look at is what happens to 0, 1. Now 0, 1 is in the y-axis, and when it's reflected in the y-axis, 0, 1 is not going to change, so it'll be 0, 1. Okay, so let's see what happens to the point xy, P, and let's find the image of P through a reflection in the y-axis, so we'll call that P dash. Multiply the first row by xy, so we turn it sideways, we've got -1 times x, which is -x, and this will be 0, -x plus 0 is -x. Turn this sideways, and we've got 0 times x, which will be 0, 1 times y is y, so 0 plus y will be y. And probably intuitively you can see that that's what's going to happen, that the y coordinate is not going to change. When we reflect in the y-axis, the y coordinate is going to stay the same. But the x, whatever is the value of x, it'll be the same distance going back if it's a reflection, and this will be -x here. Okay, so that's an introduction to representing geometric transformation by matrices. It's very easy. All you've got to do is to get the first column, it's always what happens to 1, 0, and to get the second column, it's what happens to the point 0, 1 through that transformation.